10 most impossible things to transport in the world. Number 6 broke the Guinness World Record. 150,000 tons ranks number 3. Each one leaves people absolutely shocked. TOP-10 ultra-heavy mining trucks. Transporting a complete ultra-heavy mining truck is like moving a steel mountain along the highway. These giants that operate in mining areas are already 7 to 8 meters tall and over 15 meters long. Just the wheels make adults look as small as children, with the entire vehicle often weighing over 600 tons. Transporting such a massive machine directly from the factory to the mining site is an extreme challenge for modern transportation technology and organizational capability. This transportation process isn't just breathtaking, it's more like a carefully directed steel ballet. Each kilometer requires meticulous planning and powerful execution. The convoy transporting such a complete mining truck is usually massive in scale. The heavy-duty towing vehicles are extremely powerful, sometimes requiring 2 to 3 power units working together to push or pull this monster forward slowly. Since the vehicle's height and weight far exceed normal vehicles, to avoid crushing roads or bridges, transport routes are surveyed in advance. The load-bearing capacity, turning radius, and slope of each road section are carefully calculated. Some routes even undergo special reinforcement construction, such as widening roads, thickening bridge surfaces, or installing temporary support frames, just so the giant vehicle can pass safely. The convoy's speed is extremely slow, often only 5 to 10 kilometers per hour, but each slow turn feels like pushing the limits. The huge vehicle body slowly shifts, accompanied by the low rumble of engines. The scene is both magnificent and tense. During the transportation process, the entire truck resembles a moving fortress, usually escorted by police cars and engineering vehicles, with traffic police temporarily closing roads along the way, making the road completely clear for its passage. Such transports are often scheduled for late night or early morning, when city streets are empty. The massive vehicle's silhouette resembles an ancient giant, traveling through the human world. Every time it passes a sharp turn or bridge, on-site staff communicate in real time via walkie-talkies, with coordination precise to the meter, ensuring the vehicle's tires don't scrape guardrails or sink into road shoulders. Into 2018, a mining truck transport in Wyoming, USA, drew widespread attention. That giant truck weighing 635 tons. Once loaded onto the flatbed transport vehicle, the total weight of the vehicle and trailer approached 1,000 tons. The convoy took 3 days to reach the mining site from the city outskirts, covering about 120 kilometers. During transport, each bridge was precisely calculated, with temporary traffic control arranged. The entire transport operation was like an engineering miracle. Similar transport scenes are common in Australia, Siberia, and other mining-developed regions. Those winding mountain roads and desolate highways often witness these beasts, moving slowly but steadily forward. Transporting complete ultra-heavy mining trucks is not just a high-difficulty operation in the logistics industry, but also a symbol of industrial power. From route design to convoy coordination, road reinforcement to real-time monitoring, all of this crystallizes the wisdom and courage of engineers and drivers. Each mining truck that successfully reaches its destination represents a grand collective effort, as if painting a magnificent scroll for modern industry. On the highway, sunlight outlines the massive vehicle's silhouette as it slowly passes through cities and wilderness. This is not just transportation, but more like a grand display of human and machine power. TOP-9 oversized aircraft components. The Airbus A380, known as the King of the Skies, has wings spanning nearly 80 meters, with a fuselage length equivalent to a city block. Manufacturing such an aircraft requires collaboration across multiple global locations, and bringing these massive components to the assembly line creates scenes that leave people breathless. These steel giants must travel on highways in the dead of night, completing a journey that seems like something from a movie. When night falls, the rural roads of southern France suddenly become brightly lit. The 10-meter-long wings are firmly secured on a specially designed low-platform transport vehicle. The vehicle body is extremely low, almost hugging the ground. It's equipped with dozens of independently steerable wheel sets, like a giant mechanical caterpillar, winding forward on narrow roads. The convoy advances slowly, with police cars flashing lights leading the way, and escort vehicles following behind, like escorting a silent king through the night. The wing's massive silhouette covers the entire road, like a moving steel wall, slowly gliding past roadside fields and houses to welcome such a giant. The highways have been customized for it. Corners widened, bridges reinforced, some traffic signs and light poles removed before transport, some power lines temporarily raised, all to allow this giant to pass smoothly. Workers wearing reflective vests, holding walkie-talkies, stop to adjust direction with each step. A single turn might take 10 minutes. Each wheel set's angle is precise to the millimeter. The entire transport process resembles a silent dance, slow yet full of tension. Villages along the route seem to hold their breath. Residents open their windows, standing at doorways watching quietly. Some children sit on their parents' shoulders, wide-eyed at the unprecedented giant passing by their homes. Spotlights illuminate the road like daylight. The convoy passes through slowly, like a silent industrial ceremony. For onlookers, this is a rare spectacle. For the workers, this is a zero-error mission. Each operation is like walking a tightrope. This is not just a transport, but more like a precise city-scale performance. Each time an A380 wing or fuselage section departs, hundreds of people prepare and coordinate behind the scenes. Route design, traffic control, to vehicle technical adjustments. Every detail demands zero error. A small calculation mistake, even overlooking the height of a power line, could bring the entire plan to a halt. The transport team is thus described as dancers. They direct the massive convoy, dancing to an industrial rhythm through sleeping village streets. Such transport is not just a logistics link, but a stunning industrial narrative. When these giants finally reach the assembly plant, to be assembled into aircraft that soar at high altitudes, people can hardly imagine that their journey began with such delicate patience and precise coordination. Every slow advance on midnight highways is one of the most spectacular chapters behind the aviation industry. TOP-8, submarine. Just as dawn breaks over the city horizon, a giant transport vehicle slowly enters the spacious highway. They are massive in size, with a giant presence on their trailer. A real submarine makes people. Instead of silently cruising in the deep sea, it's mounted high on a specially designed chassis, moving slowly under the gaze of the highway. This scene has tremendous visual impact. The submarine's steel hull gleams with a cold luster in the sunlight. Ordinary cars passing beside it look like toys in comparison, as if the highway momentarily became an exhibition hall for giant carriers. This is the unique charm of road transporting submarines, taking what belongs in the deep ocean onto land, allowing people to experience up close the impact of industrial manufacturing and the weight of national strength. Road transport of submarines isn't a simple logistics operation. It's a carefully planned engineering miracle. Modern submarines are typically 70 to 80 meters long, with displacement of thousands or even tens of thousands of tons, weighing more than thousands of cars combined. Massive in size and precisely structured, a slight mishap could cause hundreds of millions, or even billions in losses. Therefore, each transport is a huge test for the engineering team and logistics system. To meet these special requirements, transport vehicles often use multi-axle hydraulic flatbed with up to dozens of axles. Each wheel can independently adjust direction and height, ensuring balance when passing through narrow turns or uneven road sections. These vehicles are like steel caterpillars, crawling at extremely low speeds. Each start and stop is precisely calculated. Such a project is comparable to a grand cross-departmental exercise, involving police, traffic management, construction engineering, shipyard coordination, and other departments working together. Each step cannot tolerate the slightest error. Looking deeper, this transport is not just a technical competition, but a symbol of comprehensive national power. Countries capable of manufacturing and transporting submarines must possess strong shipbuilding industrial systems, and massive infrastructure networks. Therefore, road transport of submarines is not just a seemingly slow journey, but a concentrated display of a nation's industrial system, logistics, organizational capability, and technological strength. Each submarine's movement on highways is a moment of industrial epic slowly unfolding. It allows people to feel the massive scale of modern civilization and the mysterious presence of deep-sea power. Perhaps in the future, as more cutting-edge equipment travels this way, from inland to the ocean, people will gradually become accustomed to seeing this sight. Steel giants no longer belong only to the deep ocean. They will also silently pass through city streets, like a giant awakening from slumber, heading toward the vast deep blue world. Top 7. High-speed rail bridge transport. On the highway in daylight, sunlight glimmers on the straight asphalt road, like laying out a path leading to the distance. The entire scene is solemn, like a carefully choreographed ceremony. In the center of this empty road, a giant is slowly moving forward. That's a special truck specifically designed for transporting high-speed rail bridge beam equipment. The vehicle body is long like a dragon, steadily carrying a steel giant on its body. A high-speed rail beam carrier. Under the scorching sun, the beam carrier's cold metallic luster is dazzling, like a steel beast resting quietly. Its massive size and silence make the entire road solemn. The low rumble as wheels roll over asphalt is particularly clear in the empty afternoon. The air is filled with tension and solemnity. Each movement, in turn, tests the engineering team and drivers' tacit understanding and courage. The high-speed rail beam carrier, this seemingly ordinary name, is an indispensable core equipment in high-speed rail construction. It shoulders the tasks of hoisting, transporting, and installing high-speed rail bridges. And the concrete box beams it carries are often 30 meters long and weigh 700 to 900 tons. They are the backbone of high-speed railway bridges. To support these giants safely and precisely reach construction sites, China has manufactured world-leading special transport vehicles, the most representative being the high-speed rail 900-ton box beam transport vehicle. These transport vehicles are dozens of meters long, equipped with 10 independently adjustable hydraulic wheel axles for height and direction, shaped like a winding steel dragon. Each wheel can independently exert force, allowing these giants to move rock steady on winding highways and narrow country roads. In the sunlight, the giant transport vehicle stands out on the highway. Many drivers slow down to watch. Some take out phones to photograph this real-life moving engineering wonder. Such transport operations aren't simple equipment transfers, but precise engineering collaborations. Each route undergoes months, or even half a year of repeated planning and simulation. Bridges along the way are evaluated for load capacity in advance. Some are even reinforced. Overhead power lines, road signs, and traffic lights are raised or removed beforehand to create enough space for giant convoys to pass safely. The entire transport process is like an industrial dance across the city, each detail precise to the millimeter, allowing no margin for error. The 900-ton beam transport vehicle isn't just a transport tool, but a symbol of China's manufacturing and infrastructure construction capabilities. As China's high-speed rail network total mileage exceeds 40,000 kilometers, these transport vehicles work day and night, moving heavy beam components from the manufacturing plant to construction sites, then precisely placing them on bridge piers, laying out the crisscrossing high-speed rail network. You could say, behind every high-speed rail bridge are countless slow and determined journeys by these transport vehicles. They are like silently flowing steel blood vessels, injecting continuous power into China's high-speed rail miracles. Top 6. The real move. Moving house is one of the most headache-inducing things in many people's lives. Packing, loading, unloading, organizing. Each step is physically and mentally exhausting. Even if you hire a moving company, it's still chaotic and busy. Imagine if instead of furniture and miscellaneous items, the entire house needs to move. What an unimaginable scene that would be. Engineers have actually achieved this without dismantling a single brick. They lift an entire building and deliver it to a new location, like moving an oversized artwork. With precision and delicacy, this isn't just the ultimate version of moving, but the display of human engineering wisdom. Wuzhou City in Guangxi, China State, an amazing moving show like this. The Fugung Building Relocation Project. This building, about 30 meters tall, weighing over 15,000 tons, was completely relocated more than 30 meters from its original site, becoming the heaviest building ever relocated at that time, breaking the Guinness World Record. The project was implemented by Guangdong Lubin Company, from preliminary preparation to execution, crystallizing the efforts of countless engineers and workers to keep this giant stable while moving. The engineering team precisely calculated every pillar of the building, made precise calculations, installed numerous steel frames and supports at the base, placing the building on a synchronously controlled hydraulic jack and rail system. This way, the Fugung building stood up from its original foundation and was gently pushed to a new location. The entire process lasted 11 days, moving at a pace so slow, just meters per hour, but it was this slowness that ensured the building's safety. Relocating such a heavyweight building is a pinnacle achievement in engineering. Imagine a building weighing over 10,000 tons, its weight equivalent to thousands of cars. Combined, making it walk steadily requires multi-party coordination and precise calculations. The building's structural safety and redesigning surrounding roads. Every detail cannot have errors. The walking mechanism beneath the building is like an iron runway prepared for the building. Through low friction pads and traction systems, it moves forward silently under slow pushing. The entire process is like a large-scale surgery. Technical staff constantly monitor tilt and stress data. At the slightest abnormality, adjustments are made immediately. The Fugung building's relocation was a magnificent engineering marvel and a profound urban lesson. It tells us the power of technology isn't just reflected in the height of steel and concrete, but in cherishing and protecting urban memories. Engineers use cold equipment to complete a surprisingly warm feat, allowing a historically significant building to continue existing in another way on the map of this city. TOP5 Wind Turbine Blade. When the first morning light falls on country roads, a wind turbine blade transport convoy has already quietly departed. The tractor's body has been specially reinforced, equipped with hydraulic control systems that can adjust the blade's angle in corners, ensuring they safely pass through narrow roads and low bridges. The blade rests on the frame like a sleeping white giant. Its slightest movement affects the driver's heart. These scenes are like a performance, a slow-motion art in the real world that leaves people in awe. According to International Renewable Energy Agency data, the length of a modern wind turbine blade has increased from 20 meters in the 2000s to 80 meters or even longer today. And as wind turbine power capacity continues to increase, giant blades exceeding 100 meters will appear in the future. Transporting such massive structural components requires specialized extendable trailers and fully hydraulic modular vehicles. Each transport trip costs between $50,000 to $100,000. More complicated is that many wind farms are built on mountains, canyons, or coastlines with uneven roads to destinations. This places extremely high demands on route planning. Engineers often need to survey sites months in advance, using 3D modeling to simulate vehicle paths. Sometimes even building temporary roads specifically for transport, widening turns, reinforcing bridges. The handling of every detail reflects the high professionalism of the entire industry. During the transport process, people not only see modern industrial power, but also feel the subtle interaction between humans and nature when blades pass through fields and villages. They often attract roadside residents to stop and watch, perhaps seen up close for the first time. Such massive clean energy equipment, thus understanding more intuitively how wind power transitions from blueprint to reality. For many villages and towns, these convoys carrying white giant wings symbolize future energy construction, bringing new economic vitality and development opportunities. Behind wind turbine blade transport is not just an engineering challenge, but the embodiment of a spirit. This is a system engineering project requiring extreme coordination. Every driver, guide, and dispatcher is an indispensable cog. They wait patiently at highway exits before dawn, carefully adjust at mountain road corners, move forward with lights and snowy nights. Also, these wings of wind can reach their destinations. Two stand on mountaintops or coastlines, conversing with the wind, humming with clean energy. Each completed transport is a victory of power and wisdom. Also a small step in the global advance toward a green future. What makes wind turbine blade transport fascinating? Not just because of its size and magnificence, but because it crystallizes the pinnacle of human industrial design and the beautiful pursuit of environmental ideals. Watching those white blades like giant feathers, slowly crossing highways, as if the future's wind is already blowing at their tips, heralding a new era of cooperation between humans and nature. Top 4. Space rocket. When a rocket shoots flames from its launch pad, with deafening roars filling the sky, that magnificent liftoff scene stirs excitement in people's hearts. However, before this moment, this steel giant standing dozens of meters tall, weighing hundreds of tons, has actually already experienced a low-profile but breathtaking journey. Rockets aren't manufactured at launch sites. Each component, each section of the rocket body, is carefully crafted in distant factories, then precisely transported to the launch site to wait for ignition beside that tower, symbolizing humanity's exploratory spirit. Such a massive yet fragile machine. How does it safely reach its destination? Behind this is a perfect combination of logistics, engineering, and science, another demonstration of human wisdom. Modern rockets typically have diameters of several meters, heights exceeding 50 meters, weighing hundreds or even thousands of tons. Their structure is extremely complex, with transportation requirements approaching stringent levels. Rockets contain precise electronic equipment, propulsion systems, and fuel tanks. Even minor vibrations or tilting could cause potential hazards. Therefore, rocket transport isn't simply moving house, but an engineering operation requiring scientific planning. The American Aerospace Transportation System is a classic example of global rocket logistics engineering. NASA built specialized roads and railway networks to transport the Saturn V rocket. This giant, weighing over 3,000 tons, from the Mississippi test site to Florida's launch center, was itself a miracle. Even today, NASA still uses one of the world's most famous transport vehicles, the Crawler Transporter. This giant crawler is 40 meters long, 8 meters high, weighing 2,700 tons, capable of moving at speeds less than 2 kilometers per hour, carrying both rocket and launch platform to the launch pad. It's so massive that it makes the ground slightly tremble when moving, but through precise hydraulics and computer control, achieves stable as a mountain. In the commercial space sector, SpaceX has also redefined rocket transport in its own way. Their Falcon 9 and Falcon Heavy rockets use modular design. The rocket can be segmented, transported to the launch site by road, then assembled on site. This method not only reduces transport difficulty, but also improves efficiency. Between rocket manufacturing and launch, rocket transport scenes often carry a cinematic quality. At night, escort vehicles flashing warning lights illuminate the road ahead. The slowly moving truck seems like a messenger carrying the future. The huge rocket body rests quietly on a special frame, like a sleeping work of art. While every worker along the way maintains extreme focus, ensuring every second of the transport journey is safe. For the public, this might just be a behind-the-scenes step before rocket launch. But for engineers and technical staff, this journey is as important as the final ignition launch. It's precisely this meticulous, cautious transport process that pushes humanity's interstellar dreams toward reality. From NASA's crawler transporter to SpaceX's modular transport solution, every kilometer the truck slowly traverses is a solid foundation in humanity's space exploration journey. When the rocket rises from the launch tower, that moment of glory was already brewing in the long, detailed transport journey. TOP-3 Offshore Drilling Platform. Offshore drilling platforms, these steel beasts standing in the deep sea, are important symbols of humanity's challenge to nature's limits and energy exploration. Their size is impressive, typically weighing between 40,000 to 100,000 tons, while super-large platforms like Big White Shark exceed 150,000 tons, comparable to a fully loaded aircraft carrier. Platforms stand permanently amid waves. Like isolated sea fortresses, guarding operations day and night. Extracting oil and natural gas from thousands of meters below the seabed. These platforms aren't built directly in the deep sea, but by coastal shipyards and high-end equipment manufacturing bases, after years of precise design and construction. After completion, they experience a complex and spectacular expedition, being transported whole to deep-sea operation areas. Among various transport methods, the most impressive and commonly used for semi-submersible platforms is towing transport, moving these offshore skyscrapers across oceans using tugboat power toward their destination. The uniqueness of towing transport is it can transport the platform intact to its destination, avoiding high-risk assembly operations in harsh deep-sea environments. This process is typically carried out by ocean-going tugs. With tens of thousands of horsepower, the transport team plans detailed routes and cable tension calculations, ensuring platform stability throughout the 1,000-mile journey. Semi-submersible drilling platforms are especially suited for this transport method because they feature a design combining pontoons and columns. They can adjust buoyancy through ballast water, moving in semi-submerged state, reducing wind and wave impact on transport. Taking the famous semi-submersible drilling platform, Seaverstrot as an example. This platform's transcontinental transport case is an industry classic, built by Samsung Heavy Industries in Korea. It's a 6th-generation semi-submersible drilling platform, designed for the world's harshest deep-water oil and gas exploration environments. Seaverstrot is about 120 meters long, 78 meters wide. Maximum operating water depth reaches 3,000 meters. Drilling depth capability exceeds 12,000 meters. Light displacement exceeds 44,000 tons. The platform deck can simultaneously accommodate dual drilling systems and large quantities of supplies and equipment. After completion, it departed from Korea, escorted by several ocean-going tugs, with over 100 tons of pulling power, taking 3 months to cross the ocean, finally reaching its designated operation area in Norway's North Sea. Throughout the transport process, the team monitored cable tension in real time, propeller operation status, and weather conditions, flexibly adjusting routes to avoid storms, ensuring platform safety and stability in complex ocean currents and harsh weather. This transport wasn't just a technical challenge, but also demonstrated the precision of international collaboration involving ship engineering, weather forecasting, maritime administration, and many other fields. Towing transport is expensive. A long-distance trans-ocean towing operation can cost millions of dollars, but its advantages are obvious. The platform remains intact during transport. No need for reassembly at the target sea area, reducing construction and deployment time, and minimizing technical risk of working in deep-sea environments. The successful transport of Seaverstrot isn't just an engineering miracle, but symbolizes the future trend of ocean resource development. Human demand for deep-sea energy continues to grow, and the continuous advancement of towing transport technology makes transcontinental construction and global deployment possible. Each platform towed to deep ocean locations is not just a floating industrial marvel, but an embodiment of technology and human exploratory spirit, witnessing the high integration and development of the energy industry and ocean engineering in the 21st century. TOP-2 Passenger Terminal in Xiamen, this city that was among the first to open as a special economic zone. Urban development surges like sea tides. The Fuzhou-Xiamen-Zhengzhou high-speed rail extends north to Fuzhou and south to Jiangdou, connecting cities along the way into a beautiful coastal arc, signaling the complete formation of Fujian's southeastern one-hour economic circle. However, on this modern high-speed rail's planned route, a massive structure blocked the way. The Xiamen-Huxi long-distance bus terminal. This narrow, elongated building weighing 30,000 tons, like a stationary steel beast, located in the northern part of the city, welcoming countless travelers for a decade, And now, it must complete an incredible journey, relocating entirely, rotating 90 degrees, moving nearly 300 meters. This super engineering feat will be written into world architectural history, considered China's largest single-building relocation project. This isn't simple demolition and reconstruction, but moving the entire building, intact from its original location to a new site. Like moving house for a city's entrance hall. Looking at the technical drawings, the Huxi Terminal main building is 160 meters long, 33.6 meters wide, with an extremely complex internal structure. The first floor hall is supported by 75 columns, with maximum distances between load-bearing points reaching 36 meters. If cut and moved to the first floor, the support structure couldn't withstand uneven forces, easily causing the building to tilt or even collapse. Engineers, after multiple rounds of verification, chose to cut at the more stable second basement level. This 30,000-ton giant was lifted like a huge piece of cake. However, getting the building to stand up was just the first step. Making it walk was the real challenge. Using the jack-pushing principle widely used in bridge engineering, engineers design a walking mechanism system, allowing the building to move step by step like a person. A huge arc-shaped foundation pit was excavated at the construction site, laying 26 arc-shaped concrete tracks. 532 walking mechanisms were installed at the main building's base, like equipping the building with over 500 hydraulic feet. The walking mechanism, through hydraulic suspension technology, continuously auto-leveled its height. Each lift and push was precise to the millimeter. In 2020, Xiamen Super Moving officially began. At the massive construction site, the giant building slowly moved, averaging 7.5 meters per day, like a giant quietly taking steps. 38 days later, this 30,000-ton terminal main building successfully reached its new location, completing a 288-meter, 90-degree arc relocation journey. After positioning, the building reconnected with its new foundation. Engineers rewelded the cut columns, poured concrete reinforcement, restoring stability equal to its original site. Today, when high-speed trains whistle past through this revitalized transportation hub, people can hardly imagine this terminal stood in its original location for many years. Then, with technology and wisdom, achieved migration. This world-renowned building relocation wasn't just for smooth high-speed rail planning, but lets people see unlimited possibilities for future urban construction. If a 30,000-ton building can move lightly, then future city layouts can be more flexible. As the engineers said, we can move a tree and make buildings walk on the earth. TOP1, Propane-Propylene Separation Tower. In the harbor's morning mist, a steel tower lies quietly on a massive transport platform. Its silhouette resembles a horizontal rocket, surface gleaming with cold metallic luster. The Propane-Propylene Separation Tower, this behemoth of the petrochemical industry, stands dozens or even over 100 meters tall, often weighing hundreds of tons. Rather than calling it equipment, it's more like a disassembled skyscraper. Whenever such giants embark on transport journeys, the entire city seems to clear a path for it. Its very existence is a display of power, making people feel at first glance the grandeur and power of the industrial age. To move the steel Great Wall from the manufacturing plant, the transport team began meticulous planning early, as core equipment in chemical production. The separation tower has complex design, with its interior filled with precise tower trays and distillation systems. Therefore, it cannot be simply disassembled, only transported whole. For this, engineers brought in specialized multi-axle hydraulic flatbed trucks. Each truck has hundreds of independently controlled wheels, like a giant's palm, able to steadily support the hundreds of tons of tower weight while moving. Road transport routes underwent rigorous surveys in advance. Bridge load capacity, turning radius, power line heights, and even tree branch clearances were all precisely mapped. As night fell, traffic was diverted. City roads were cleared. The tower, like a giant ship, slowly advanced under escort lights. Each turn was a test of calculation and technology. In transport images, this giant tower's scale is particularly stunning. It lies quietly on the trailer, the convoy extending over 100 meters, like a steel dragon winding along the highway. Its diameter is so large that road signs, traffic lights, and poles must be temporarily removed along the road. Some power and communication lines even need to be raised or rerouted. Each stop at intersections is like a carefully choreographed dance. 10 engineers and guides, with walkie-talkies surrounding the perimeter, closely watching every detail. For roadside onlookers, this scene is like a grand industrial parade. The city becomes its stage, and this giant tower is the protagonist of the Steel Age. When transport enters the factory area, the tower faces its final challenge: vertical erection. This process often requires 2 or even 3 super large crawler cranes working together, with precise adjustment of steel cables and lifting points. The entire process resembles a slow-motion performance, each lift cautious to the millimeter. The tower body slowly tilts from horizontal to vertical, the huge steel cylinder rotating in the air, like a skyscraper standing up in the field. Finally, it lands steadily on the prepared foundation, becoming the chemical plant's core equipment, silently guarding the efficient operation of production lines. Transporting the propane-propylene separation tower is the ultimate embodiment of engineering wisdom, from factory to installation. This journey isn't just equipment relocation, but a microcosm of modern industrial history. Its size and complexity command respect, while the transport process reflects the extremely high level of modern logistics, engineering technology, and organizational management. This ability to smoothly deliver a steel skyscraper to its destination, it frees industry from geographical limits. We witness the magnificent landscape shaped by technology and power.